All right, thank you for inviting me. So I'm excited to talk to you guys about the impact of data visualization on science and society and pack it all in only 10 minutes, so I will do my best. And I'm going to gear this presentation a bit towards the aspect of how do we what are a few takeaways about data visualization that create actionable engagement, specifically as it pertains to marine science. So the way I see it, knowledge dichotomies in academic science. We have these different. I love supportive graphics, by the way. Anytime you can use them in your talks, it's pretty meaningful to the lay audience. And so if we're talking about creating actionable engagement with citizens, if you can break down your science in a way that is easily digestible, that's always great. So on the left, we have more traditional academic model, kind of formality, knowledge dissemination and generation context in the sense of, formality, hierarchy, kind of rules. We're presenting information rather than allow users to explore information. That's the analytical approach. There might be some synthesis, but it's fairly, as we know, siloed. And how do we get to constructs that support more social and more pragmatic approach? And by pragmatic, I mean very like a pragmatist model, philosophy model of engagement. Kind of how we learn at recess, and rather than in school. And data visualization can help us do that. And I call myself an information designer. Data visualization designer is a bit too long, but really I care about. I break information into two ideas. And if you can't answer the first part, you shouldn't be doing the second part. So who are we trying to inform, and why are we informing them? And if you're trying to create data visualization, you should be able to answer these questions first. And then the formation part, what form should it be in, and how do we do that? And how is the fun part? You can do it yourself. You can bring in designers. You can create systems map to all get on even, within disciplines on a better page of what we're all talking about. Do we all agree about how the system works? And so I'm going to walk you through that. Lisa mentioned earlier, a few of you guys, this DIK policy system, or data information knowledge wisdom or knowledge policy. And the way Alberto Cairo, a Spanish information designer at the University of Miami, the way he talks about this is kind of exactly what you said in the beginning. We have all this. We can have acquired data, it doesn't mean anything. We have all the observable bits in the universe out there on the left, this unstructured information. We make our, we either have it go into these massive tables, that's that data section, and according to the designers in the world, that's the outer world, kind of scientists, all the people collecting data, satellites. And then where communicators come in, and whether that's someone in your group or yourself if you're excited about it, or if you have to make figures for a scientific paper, you're structuring that information. You're not necessarily synthesizing a ton of information. You're doing analysis. You might be presenting that. Sometimes you're synthesizing. It depends on what kind of paper you're writing. And then ideally, you're encoding that. There's an encoding process happening there as you turn that into structured information. You're encoding it in an elegant and beautiful way that doesn't minimize complexity but supports it, so that your user can then decode that information, right? Your viewer can decode that in the perspective of their different contexts. And what I'm missing there in terms of like the traditional mathematical model of communication as they talk about it at Bell Labs and others is that in terms of, you mentioned capacity building, there's these channels that I'm not going to mention here that we need to think about in terms of how are we encoding it and what forms. And I'll just mention it briefly as it pertains to data visualization specifically. So mainly, I fall into this left realm. Again, that knowledge tends to support itself, more can support itself. And people recall knowledge systems, that's how you get to that wisdom section, but I'm focusing on this. So visualization, as practitioner Peter Hall defines it, is really framed in three specific contexts. And I think as scientists, as policymakers, sometimes we might be aware of this and sometimes we're not. So each of these three perspectives, these framings of data visualization, have very specific biases very specific outcomes in terms of who has access to that type of visualization and can understand it. And this is not a surprise, but when we think about scientific data visualization, we think, well, there's no bias. It's of course, we actually collected it for a reason, but there's no bias. It's a tool for discovery for other scientists, perhaps each other. Through these access to data exploration, we're continuing to explore in different ways, and we're connecting that different levels of exploration. Journalistic is really focused on simplifying and explaining. There might be some bias. I only talk to you and I talk to you, and maybe I found a third party that might differ in their opinion. But the idea is that it's accessible, right? And artistic, what we do with it as a cultural and artistic company that I work for, cultural foundation I work for, is a bit more, well, how can we look at the ocean through the frame of an artistic and cultural lens and really help people explore it in a way that just ties them to nature, not even science. Let's just make that connection first. What makes a place really exciting? And why I bring this up is I think we all probably inherently know this, but often if our visualization have elements of the scientific, whether it's jargon, whether it's bizarre axes labels or acronyms, I know there's like a ton I don't even know from this workshop, it's really difficult to engage a lay audience with that and move that spectrum, those dichotomies from the left to the right. Also, you can't talk to a scientific audience if it's too kind of watered down and journalistic. So we need to appreciate these balances. Okay, so I'm just going to show you a few examples, and that's it. So 3 things to remember. Encode your information in an intuitive way. So I'm going to show you, this is for NOAA and the Nature Conservancy. I freelance quite a bit related to marine science topics because I love it so much. So this was the initial graphs. They were talking about marine species distribution shifting on the east coast of the United States, specifically with climate change. And the original table on the end and kind of figures she was looking at to show people like all these different commercially viable species and all these different assemblages that have different temperatures and different salinity requirements and different depths. How can we make this something more useful for 3 stakeholders, researchers, other scientists, researchers, policymakers, and fishermen? They want to know where their fish are going, right? So it's a little hard to see the top on the left. There's kind of a red, yellow, blue spectrum of shallow water to deeper water, warm to gold. And these 4 assemblages as laid out by their description. So this is, doesn't have the error bars, but again, furthermore, not even journalistic audience, but a bit more of a lay audience. And we thought that this was the best way of communicating that information. This is what they wanted to show for where these species have been moving with thermal habitat, all these different species that are commercially important, and they wanted to show this to fishermen, and I was like, whoa, 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 no, are they all starting in the same place? I don't even know what all these acronyms are and what species that means, and fishermen certainly won't. And so we discussed it a while and kind of using that color coding for what assemblages they belong to. Are they warm, are they deep? Are they in the Gulf of Maine, are they more south? What direction are they literally moving? If you're a fisherman, you have a compass. How far? They're not moving very far. Under 50 kilometers, we move to a little table. It's more than that. And it just gives them a sense of like, wow, I should really be fishing for something else maybe. And just to break that down, there were like zillions of species. It's really important to just highlight case studies for people. This was just looking at 3 different species commercially viable and showing green is fish, the purple up there is American lobster, and just showing like where that's the open circle is just where that species has been for the last 20 years and where we see it going in the next 60 to 80 years with the current trends of NOAA data and thermal habitat data. So this is not fishing pressures, just based on thermal habitat alone. But this was just, we were trying to make it as digestible as possible for a lay audience. Similar project, NOAA gave me this big, crazy interactive tool, but obviously just for scientists of like, here's everything we've thought about with pros and cons of negative and positive influences on all these different anthropogenic things and biological aspects, environmental, systems-based aspects. And can you make this into a bunch of small graphics that we can use to communicate between stakeholders? And I was like, and so I made 20 some odd diagrams like this for each of these groups that are much more infographic-y than I think the database, but they do emphasize and encode what influences are possible, and essentially make these design systems maps of what's at stake, what should be talked about here when we're talking about this, and what have all these scientists agreed on. All right, you should experiment with form and engagement. Often this means working with designers or working with communications officers in your foundations. I'm just going to show you two, you'll see this interactive gestural interface tomorrow outside the plenary session. But this is a piece I made a few years ago. It shows at various children's museums, as science galleries. But it shows off just the difference in the juxtaposition of biodiversity in Antarctica and what we and the public expect Antarctica to look like gray versus the amazing amount of biodiversity, colorful life that changes conversation about climate change and ensuring out there. This is a piece unrelated to the ocean. I work for a data visualization studio also called Periscopic on the west coast of the United States, and this is just to show you this basic network diagram of the last 10 years of patents between Apple and Google. So just from afar, I won't tell you the answer right away, but you can see that there's a and this is open source. The point of this is open source visualization tools like Gephi, which was used to make this, are widely available, and with a little, throw it into Illustrator, design it up, you can make something that's kind of exciting. So you can imagine, and I guess that was my question earlier, you can imagine how visualization can take this, if we think about all the different locations, for example, of databases that you're using, or you want to contextualize these frameworks in different ways, we can perhaps visualize that in an interactive format. By the way, Google is a very democratic, everybody has a patent at Google, and on the right it's just a few of the big fish have patents. And finally, it's really just important to connect to your people through our human based storytelling. We know that every time I've gone to Antarctica with the U.S. Antarctic program, people are like, "Oh my gosh, isn't it? Is it cold?" And I was like, "That's a stupid question." But that's how people have access to information. They want to know what you wear. They want to know what you eat. How do you survive down there? What's the nightlife like? They want to know the juicy bits that go in that are the context of the research, and that's again how we move the pendulum towards the right. This is just kind of whether that's observations. This is from the Italian Alps, just some sketches I did at sea. These are the things that I feel allow me to start those conversations about what science is happening in those areas. So again, if you remember nothing else, what form is best, and then how is your audience going to engage with your work? Thanks.
Thanks, very nice. For me, one of the biggest challenges that we face in an almost generic way is to present graph data in an easily interpretable way, because a lot of our more complex scientific data is about relationships between things and not just time and space and some taxonomy. So that's almost like a universal problem that we have to solve for data visualization in science. I'd like your thoughts.
Yeah, I mean, there's a number of ways specifically talking about relational data, and so I'm very curious what it is that you're talking about exactly. But I guess I would say, visually speaking, the most important thing I think that scientists and policymakers, for that matter, forget when they're thinking about graphics is visual hierarchy. And that seems like such a simple idea, but literally, what is the first, if I could throw a tennis ball across the room at the first thing I should see on your graphic, what is it? Is it the title? Are you pointing out some aspect of, like a la National Geographic, kind of some case study that will help illuminate what I'm supposed to be looking at? Is it, are there acronyms? I think another thing, gray is a secret weapon, always just gray or reduce the visual impact of data that's not as, as much a part of the narrative as the main thing you're trying to get across. So all the data is there. I'm never an advocate of watering any data down, but just visually emphasizing kind of what's the first read, what's the second read. You know, we talk about it's great having a presentation where you can, I can walk you through something or zoom you in on something. But in a poster, a static graphic, you have to do that for the reader with visual hierarchy. So being able to dive down deeper into that with font size and color, with call-outs, case studies, annotations.
Thank you. Very interesting presentation. My name is Mary Wise. I'm from the World Maritime University in Malmö, Sweden. Question about trying to communicate things almost too simply, and we might actually miss out on real, possibilities for people, for our audience to receive even more information. For example, the dynamics of the ocean. I mean, right? If we look at visualizations from something like the Global Fish Watch, those things are moving all the time, and they can convey so much more information than a static map ever could, and it also helps. Well, you can tell stories with these dynamic maps as well, and then the audience can also start to tell their own stories from what they're seeing, and so there's some big possibilities in there, and then also things like uncertainties. Trying to communicate the things that we wish that our audience sometimes understood better. The ocean moves, and there's also a lot of uncertainty in what we understand about it. And so if we make that more, if we can more effectively communicate that, the better the decision makers may be able to understand or start to come up with solutions or ideas for trying to manage and govern.
100%. I think I was speaking earlier about Examine and Explore, which is this browser-based data interface that I helped to design for the Canadian, British Columbian side of the Pacific side, and the whole point is exploration, allowing researchers, Native peoples, everyone to be able to explore the data for themselves and ask their own questions. And really interactive browser-based data interfaces can do that really well. But they cost a lot more money.